Hi, I made very short tutorial about the using of the CNC Simulator Pro software, and just a reminder that this copy is a trial version. It's going to work for 1 month and is going to expire, and I'm going to use it for doing the practical session of the CNC machining because due to the COVID restriction, we're not going to be able to operate the machine in the lab. So if I'm going to go first through the CNC machining center we have here, you can see that once again, just to explain to you the accesses we have for this machine. This will be the spindle. The tool is going to be connected to it. This vertical axis is the Z axis. The tool will go down and up along the Z axis, and also the rotation of the tool is going to be around the Z axis. Table will be moving to the left and the right along the x-axis, which is show the longest side of the table, and the shortest side of the table is going to be the y-axis. And the table, of course, is going to go forward and inward along the y-axis. You remember that when I said something about the setting on the setup of the part on the table, we are going to have the T slots, and usually we insert the T nuts inside these slots, and we're using the bolts to fix the part on the table. Now, I think that when you're going to start the software for the first time, you're not going to have the machine, but I cannot get rid of the machine right now. Just remember that to rotate this, the look of which side we're looking at the table, the machine, we're using the left click button on the mouse and remove it. Zoom in and zoom out is going to be, of course, by using the wheel, and the right click, I can move it to the left and right, up and down without rotation. Now we're going to start to do the first thing in our process is calling the machine if you don't have one. So we click on this icon, which is the open the machine, and you are going to have the list of the available machine. You can have 3D printer. Let's double click on that. We have 3D printer. We're going to go back. We can have the cutting machines like laser cutter and the plasma cutter, and we have the water jet cutter and the CNC laser cutter. Well, the South lasers, of course. Okay, if I going to go up to the machine again, we can have something just for fun on how to move a drone or how to do the gaming. We go up. We have the milling operation, and that's what we're going to use, the milling center. We have other types of the machine like the hobby kits. We have the disco router. We have, I think, the large router, which the router table, yeah, and that's something we will try to run on the TIC lab within this semester, Symmetric machine, and most of these things actually are for simulation. Some of them are for real life. What we have as well is the turning operation, and that's something else we are going to try to apply in this semester to do turning, not only the milling operations. The last thing that I didn't show, which is the robotic. We have one robotic arm, the simple, and this is kind of the hobby robotics arms that many people using for just for fun, just move the material from one side to another. We go back once again to the machining. We go to the milling and we select the center milling center, and say okay. Oh, just remember something. When we go there and select, try to untick the demo. Untick the demo. We don't want to have a demonstration. Okay, now we have the machine ready, and we are going to do the setup for this machine. In the real machine, usually this will be table as I mentioned. The center is going to be in a closed place. We usually upload the program by connecting the CNC machine to a computer. Everything, all the jobs is going to be shown here on the controller. Is going to set the value of is going to give you the value of the location. Some of the more advanced machines going to give you the shape of the 3D part while doing the machining. This is controller for the speed. We get the controller for the button for the emergency stop. And we're going to see this one actually more closer. We're going to take a look to this one. There's a small controller. You can see that I can revolve that to change the feed rate value. Okay, we have the turning of the coolant on or off, spindle on or off. It's ready for work. Um, alarm signal. Start. Go to home position. Single step for the machining. Dry running. Was that operation stop and the jogging enabling. That's mean we can move the spindle location by jogging without doing any machining. These are the location for the coordination for the X, Y, and the Z. RPM value and the feed rate value meters. Okay, so that's basically what we have. And let's start to first upload the work part on the table. If I get to take a look to the table, this was set up as the original datum point for the table. And we are going to modify the location of the datum point for the work part as we are going to put it in. So of course, before we're going to start doing anything, we're going to the setting, press the settings, and be sure that you are going to use the millimeters as unit instead of the inches. That's of course to make it the G21 instead of the G20. Okay, now we're going to start to do the work. I would like to have a part on the table. So we're pressing F2, okay, the key F2. Now you will see the inventory browser. And in this inventory browser, we have to define the tools. I'm going to remove all the tools I have on my previous setting because I'm going to make a new tools soon. Okay, so I don't have tools now. The workpieces, I'm going to remove all these workpieces and I'm going to remove the one I added, which is one of the four. This is the one from the example, so I'm going to leave it. This is the same thing, so I'm going to delete it. And we have the yeah, I'm going to do this one as well. Okay, now we have only the original one. This is for the lathe workpiece. We're going to have cylindrical shape, the material selection, and we have the 0 point location. So I will go first to the mill workpiece, and I'm going to add a new one, and I'm going to put the dimensions here to be 100 millimeter. Highlight this one and type 100. This will be for the x-axis size. This is the y-axis size, another 100. And for the z, I'm going to put the thickness of 20 millimeter. Now, I cannot choose the material right now. I need to define this one later. And this is some of the prefabricated workpiece can be uploaded also from the CAD model you have on your computer. Let's insert a cruiser. Okay. So you can see here, I added the register bar directly. Now, if I not going to do it that way, I have to type the thing. You can see that if I'm going to make a new line, I'm going to make the dollar sign, dollar sign, and I will write ADD and capital REG. You can see that I can add the add register part workpiece from the registry. But the process was much easier when I again to select the add of the cruiser, then the line will show up here directly. Now you can see that I don't have the work part here, so I have to bring it in. Just simply by press of the play or the start, I will bring the part on the screen as you can see here. Now you can see that the location of the datum point is here, and I would like to push the part away and put the datum point at this corner. Now to do that, I'm going to go to here and I'm going to define the following. First, on this cruiser, I'm going to put a comma after the 2, and I will type 30, comma 30. And I'm sorry, I got 40 because I'm not looking at the keyboard at the moment. 30 and 30. Just be sure that you're going to have a space there. Now you will see what will happen when I get to press the play. I push the datum point to be here. Now I would like to go to this height. So I'm going to add another line, and this will be the G92, which is defining the the datum point location G92, okay, which is set the zero offset as you can see here, set the zero offset to define the location of the datum point on the work part itself. So G92, then again to define the location, you can see that actually this point is 30 and 30 for the X and the Y, but the Z should be go to uh, 20. So I will put here the X is 30, and of course the best format should be 0.00, and the Y is 40 again. Sorry, Y is 30 again, 0.00, and the Z is going to be equal to 20. Now, you can see what will happen if I again to press play. Now, this is the datum point. This is the datum point now. Is at the top corner to the, well, I'm going to say, see the thing from the top. It's going to be at the bottom lower corner to the left. Instead of doing that, I can simply press that, and this will be resetting the view. And I think that I have something else to make it much closer. So anyway, I will leave this one. This one actually is going to replace the F2. If I'm going to press on this one, I will go to the inventory table. I would like to add tool to my work. So I'm going to add the first tool, and the first tool I'm going to use the flat cutting tool. I'm going to put the diameter to be 10 millimeters, and the length here is going to be 50 millimeters. I made the first cutting tool. If I'm going to use separate shaft, then I'm going to add the number of the teeth I'm going to have on this one. Usually for this one, the standard is going to be 2 floats. Now the tool name is going to be tool number 1 because this is my first tool I have on my work, or I can call it tool 1, tool uh, 1. Okay. That's my tool number 1, and I'm going to say, okay, now I got my first tool. Let's add another tool. It's going to be, for example, the ball nose if I would like to do this, the contour shapes, and the point if I'm going to have the drilling operation. So here I'm going to have the diameter to be 10 again, and the length is going to be 50. And of course, I need to define the tip angle, and usually tip angle is going to be 80 degree for the drilling tips. Now say OK, and we have 2 tools now. You can check that from the list. Tool 1 and tool 2. Okay, just registering that as my milling tools because we are going to have another one for my lathe tools later in our work. Now, I can insert the first tool at the cruiser. Okay, and now we are going to bring the tool by adding after that the M06 as you remember. Okay, M06 execute the tool change, and I say okay. Okay, now if I get to play the thing, the tool will should show up. Now the tool is already here. Now we got the tool. The other thing we need to do is, before we're going to do any movement, we need to turn on the spindle. So anyway, I'm going to write down G00, and I'm going to write down that the X equal to 30, Y is equal to 30, and I will send the tool to the Z equal to 2. Here I need to define the position, which is going to be bringing the tool above the work part, and it's going to be floating at the height of the uh, 2 millimeters. So it's going to 2020, and it's floating at 2 millimeter. Now you can see that the 30 and the 30 is going to be defined from this position. I can change that to 2020. I will try to write down something like the alpha or the A in the Old Greek language. So I will send the cutting tool to 2020. Then I'm going to take it to the top and bring it back to the bottom. Okay, now we got the first movement. Now I would like to insert the cutting tool inside the work part. That means we need to have the spindle rotating before we're going to do that. So at this stage, I can write down we are going to have the M03, which is going to be the spindle start clockwise space, and I'm going to define the spindle speed. Let's say it's going to be 1000 RPM. Now, I don't know if this one is going to show you that the cutting tool is rotating, but now it should be rotating at this moment. It's not showing that. Now, here I'm going to write down the G01 and going to the Z equal to minus 5 millimeters. Let's make it minus 2 millimeters. Okay, and of course, I need to define the feed rate, and I will choose the 250 millimeter per minute. Insert that. So now I'm going to repeat from the beginning. The cutting tool will come, and now it's went inside the work path. Now my next location is going to be to the top here, which is going to be half midway to the X, which is 50, and just below the end by 20 millimeters. So the X50 and the Y is going to be 80. Okay, and I'm going to keep the same feed rate. So I'm not going to change anything regarding the Z or the feed rate. So I can write down that directly as the X is equal to 50, Y is equal to 80. Okay, and well, I'll going to drop down the value for the feed rate. Feed rate is going to be 150. Okay, now let's play that now. It's coming to the bottom and move to the top. And now my next step is again to bring it down to here. So you can see that I didn't repeated the G01 because I'm still using the G01. Now let's try to think about making an arc here, an arc. And I'm going to choose that the center of rotation is going to be the original point here. So let's try to do that, G02. And I'm going to write down that the final X is going to be equal to 80. And the final Y is equal to 20. Okay, oh, that's Y. Y is equal to 20. Okay, and the R should be defined, and the R is going to be equal to, oh no, let's use the I and the J. The I is going to be 20, and the J is 20. Okay, and I'm going to slow down the feed rate further to be 80 millimeter per minute. I'll start to work. Oh, it's giving me now an incorrect error. I think that the main error came from, let's have a look. I20, J20. Yeah, this one was 2020. That's right. Anyway, let's use it as an R. So in this case, the radius is going to be equal to, I will choose any figure right now. I'm not going to bother myself about this one, about the calculation. And I'm going to add it as 60 millimeters. And let's try to give it a try. Okay, reset and play. Oh, yeah, yeah, yeah. Okay, so it did the arc. So this was a very simple example. And I will give you another work of I'm going to make a hole here, then go to the left and try to make an enlargement for the pocketing here. So I'm going to send the cutting tool up by sending the tool to the G00 Z equal to 2. Okay, then I will go to the X equal to 50, let's say. And let's make it X 50 and the Y is equal to 30. Y 30. Okay, and let's see what the cutting tool is going to end it up. Is that a good location? Um, that's not a perfect location, but still, I'm going to push a little bit to the side. So I'm going to set uh, the X to uh, 60 instead. Okay, and our cutting tool location is going to be a little bit to the right. Okay, yep. So I'm going to drill a hole here, then move a 5 millimeter to the side, and try to make a full circle here. So now G01, and I'm going to send the Z to -3. Okay, and then I'm going to go to the G01, and I'm going to send the X to 55. Okay, so X 55 without changing the Y value. And then I'm going to do the G03, and I'm going to make the location to be back to the point where the X is equal to 55 and the Y is equal to 40. X 55. I just try to do a full circle. Y is equal to 40. Okay, and the I is going to be equal to, in that case, the X 60, Y 40. X, oh, sorry, yeah, 60. I hope it's going to work this time. I, J, J, 40. Okay, now let's try to give it a try. I hope it's going to work right now. Oh, it's going to give me error. I'm not sure about that. Oops, 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 oops. Okay, so it's okay. So this was yeah, yeah. Because I think here is using the incremental instead of using the absolute for defining the I and the j. That's why we have the mistake. So the I is going to be 5 in that case, and the j is going to be equal to 0. Okay. Now let's try to give it a try again. Ah, yeah, yeah, I got it. Okay, so it was using the incremental instead of the absolute to use the I and J and the J. Anyway, I use the I and the J because I'm sure that this one is going to give me the full circle. Now, you will say, okay, now what's that? Why we have it as a stipper? Now, mainly because the resolution of this software is not that high. It's not because we're doing a wrong cutting. Okay, so this I think that's enough. Now you can copy any code you make and put it here, and you can make any shape on your own work part, and you are going to be within few times, a short time professional with the work. Actually, the part we made with the assignment, number one, you can bring it to here. You can bring the same code with your own work part, define the center location. You can even put it in the center if you would like to have the 0 point to be in the middle, and then show us that how you do the machining operation by using this simulator tool. Okay, thank you very much, and I will try to make another one for the turning operation.